Hi viewers, you are welcome to Catch Up Math channel. In this tutorial, I will be teaching you the shortcut to solve implicit function. So now, when you look on the board, the question we have here, you are asked to find the y, the x of the following functions. So we have three questions here. So how do you obtain the implicit function in a space of 1 minute? Okay. Now the first thing you have to understand is the definition of implicit function. Okay, that is when you are given any function, how do you separate implicit function from explicit function? Okay, the definition is any function of the form f of x, y is equals to 0. Is called implicit function. So when you have any function which is given in this nature, in this form, is called implicit function. That is, y cannot be completely separated from x. So a function like that is called implicit function. Now let's look at the first question you have here. Question 1. You are given x squared y plus xy plus x cos y. The minus y squared is equal to 0. So you want to differentiate this because you have to differentiate this function to get the y dx. Okay, how do you obtain this? This is very simple. I'm going to use this shortcut for you. I'm going to teach you this shortcut that will help you to solve this question in a space of 1 minute. Even lesser than that, okay? Don't forget, we are actually looking for the y, the x. This is what you are looking for, right? Okay, and you are going to have something like this, minus. Then you have a space like this. Okay, don't be confused that, okay, how do you obtain these brackets? Okay, now we are going to find something and insert in this place. Likewise, you are going to find a function and insert in this place. So what are we finding? What are we looking for? That's the next question, right? Okay. You see this function you are given. This is your f of x, y is x squared y plus x cos y minus y squared. Okay. So the numerator here is that you just have to differentiate f of s, y, this function with respect to x. So you differentiate this function with respect to x and you have to keep y as what? Constant. You are going to differentiate this function and keep y as constant. So this is what you are going to get for this side. Okay, why that of the denominator function is that you are going to differentiate this with respect to y and keep x as constant. Okay, if you actually understand that, okay, let's see how to differentiate this with respect to x and keep y as constant. Okay, fine. To differentiate this, you have differentiate x squared y, you have 2xy. Don't forget we are differentiating it with respect to x. Now differentiate x here, you have 1, but don't forget you have cos y in this place. So this is 1 multiplied by cos y, and that will be what? Plus cos y. Okay, do you have to differentiate this? No, because this is be your constant. When you differentiate y squared with respect to x, you are going to have what? You are going to have 0. Okay, now to the denominator part now. I told you that you have to differentiate this one with respect to y and keep x as constant to get this denominator function. Okay, now you have y in this place. When you differentiate y, you have 1. 1 multiplied by x squared, that's x squared. Okay, when you differentiate cos y, you have what? Minus sin y. But remember, you have x in this place. And that will give us what? Minus x sin y. Okay, we have minus y squared. Differentiate minus y squared, you have minus 2y. So, and this is the derivative of this. So this is the final answer to that question. You can see the question is very simple to solve using this trick, using this shortcut. Okay, second question. Question 2. You have exponential xy minus 2x y squared plus x squared is equal to 7. Okay, now you can write this in form of f of x y to be s exponential xy minus 2xy squared plus x squared minus 7. Okay, don't forget we want to differentiate this. That is the y dx. Okay, we are still using our 3. Okay. So now you have to differentiate this function with respect to x to get this. But don't forget, I told you earlier that when you are differentiating with respect to x, you'll be keeping y as what? As constants. Okay. Now when you differentiate exponential xy with respect to x, you are going to have y exponential xy. If you differentiate to x with respect to x, you are going to have what? Minus 2. But you have y squared here. This will become minus 2y squared. Okay? Differentiate x squared, you have 2x. Do you need to differentiate this? No, because this 7 is constant. And don't forget that when you are differentiating a constant, you are going to have 0. Okay, to get the denominator function here, you are going to differentiate this function with respect to y, and you'll be keeping x as constant. Okay, when you differentiate exponential xy with respect to y, keeping x as constant, you have x exponential xy. Okay, now differentiate y squared with respect to y. That is what? 2y. When you differentiate y squared, you have 2y. But remember, you have minus 2y there already, which is minus 2y multiplied by 2y, and this will give you what? Minus 4xy. So we are going to have minus 4xy. Okay, now differentiate x squared with respect to y. That's what? 0. Differentiate 7 with respect to y. That will give you what? 0, because 7 is constant. So that is the y dx is minus y exponential xy minus 2y squared plus 2x. Then divide by x exponential xy minus 4xy. So, and that's the final answer to the second question. I'm sure you understand how to solve implicit functional without any stress. Okay, so you can just solve the last question on your own. So I'm sure you can solve that now. Okay, don't forget to subscribe and like our